So today we are going to solve content duplicates problem. So the problem statement says that they have given as an integer array nums. We need to return true if any value appears at least twice in the array, or else we need to return false if every element is distinct. So let us understand with the help of examples. So if you see the first example, we have an we have an array with which consists of four numbers 1, 2, 3, 1. If you see, element 1 has been repeated twice, right? So they said that if an element repeated at least twice in the array, then we need to return true. So the answer for this is true. If you consider the second example, there are four elements 1, 2, 3, 4. Each element is occurring only one time. That means each element is distinct. So the answer is false. If you consider third example, there are occurrence of 1 which is occurring 3 times, 3 is occurring 2 times, 3 is occurring 3 times. If even one element is occurring more than one time, we need to return true. So the output is true. If you see the constraints, nums dot length, at max it can be 10 to the power of 5, right? And each number can be from minus 10 to the power of 9 to 10 to the power of 9. Now let us try to understand how what are the multiple ways to solve this question. So let me take the first example 1, 2, 3, 1. So if you consider 1, 2, 3, 1, we already know that 1 is occurring twice, right? How to solve this question? First, let us try to understand the brute force approach. If I consider 1, if I fix 1, then we need to check is 1 occurring on the right side or not. That means we need to check each and every element on the right side of 1, and we know that 1 is occurring on the right side. So we can return true, right? What if our array is 2, 3, 1, 1? Now we fixed 2 as the first element and we are searching for 2 on the right side. Did we found 2? No, we don't have 2 on the right side. Now we need to fix 3 and we need to check right side of 3. Do we have 3 on the right side? No, we don't have. Now we are fixing 1 and we are checking on the right side for 1. Yes, we encountered another 1 on the right side. That means 1 is occurring more than once. So we need to return true. Correct? So this is approach 1. That is brute force approach. So let me show you the code for this. What are we trying to do? We are fixing a number and we are searching the same number on the right side of the array. If we found that element, we are returning true. What if, okay, before moving on to the coding part, what if we have an array 1, 2, 3, 4? We obviously know that answer is false, right? But let us try to understand with the help of approach. We fixed 1, we searched on the right side for 1. We don't have any 1 on the right side. Now we are fixing 2, we are searching on the right side. Still we did not found any 2. Now 3, we don't have 3 on the right side. Now 4, we don't have any element on the right side of 4. So we can stop here. And since we did not encountered any repetition of any element in the array, we can return false. So let me show you the code for this. So yeah, what I am trying to do is I am trying to run a loop from 0 to last element, and now I am searching on the right side. So I am starting another loop which is running from I plus 1 to last element. If the numbers are same, then I am returning true, or else after completion of these loops we need to return false, saying that we did not found any element on the right side. Now if I submit this code, it leads to time limit exceeded. Okay, let us run this first. Sample test cases are passed, but when I submit this, internal hidden test cases are uh, too huge, so it is leading to TLE. So let us try to understand why it is leading to TLE. Since we are running two loops, these are nested loops. So one loop is running till n, and each loop is running for all the elements on the right side. So in worst case time complexity will be big O of n square, right? So if you see this element, what is the size of n? If you see this nums dot length constraint, the length at max can be 10 to the power of 5. N square, if n is 10 to the power of 5, what is n square? It's 10 to the power of 10. We know that in 1 second our computer can perform 10 to the power of 8 operations. So since 10 to the power of 10 is more than 10 to the power of 8, it is leading to time limit exceeded. Now we need to think of a better approach. So let us try to solve this question with another approach. Let me take the same example. What if I sort the array? If I sort the array, I'm going to get a sorted array, right? Now we know that in sorted array, if the number is repeated, the number will be the adjacent element, right? Since one is repeated twice, we will be having equal adjacent elements. So what I am going to do is, after sorting, I will check do we have any adjacent element which is equal to the current element. If we found any adjacent element which is equal to current element, I will return true, saying that I found a duplicate. If I don't found any adjacent element, I will return false. So if I consider another example, 1 2 3 4, this is already a sorted array, right? So I am checking, I started from the first index. Let me write the index numbers. I started from index 1. I am checking the left adjacent element. Since they are not equal, I am moving forward. Now I am checking the left adjacent element. Even they are not equal. Even for I am checking for index 3, even they are not equal. So finally I am returning false, saying that I don't have any duplicate numbers. But what will be the time complexity for this? Sort takes big O of n log n. So after sorting, what we are trying to do? We are running a loop from index 1 to last index, right? So can I say we are running one loop from index 1 to n. Its time complexity will be big O of n. So overall time complexity will be big O of n log n, right? So let us try to write code for this. Let me show you the code for this. I already solved this question. Yeah. So if you see, I have sorted the numbers array. After sorting, I started iteration from index 1 till last index. If my current index element is equal to the previous index element, then I am returning true. If I do not found any element which is equal to the previous element, then at last I am returning false. Let me run this code. It got accepted. If I submit this, even this will get accepted. Yeah, this got accepted. but the time complexity for this is n log n. We have a better approach to solve this. Let us try to understand that better approach. This can be solved using set. So in mathematics we know that set is a collection of distinct elements, right? We have they have given us a number integer array. Let me write the same array 1 2 3 1. This is our nums array. Let me create a set. We know that set is a collection of distinct elements. If I consider a set S, if I keep on inserting the elements into the set, I have inserted 1 got inserted. If I insert 2, since 2 is not present, we have inserted 2. If I insert 3, 3 got inserted. But when I insert the duplicate element, that is 1, since 1 is already present in the set, it doesn't get inserted. So these are the elements in the set. What is the length of our nums array? It is 4. So length of our nums array is 4. What is the length of our set? It is 3. Can I say when set length and nums array length, if they are not matching, that means we have a duplicate number. Okay, let us try to understand with some other example. Let us consider this is our nums array. If I insert all the elements into the set, since they are distinct, all the elements get inserted. Now what is the size of our nums array? It is 4. What is the size of our set? Even this is 4. Can I say when nums array size and set size, if they are equal, then we don't have any duplicates. In that case, we need to return false because there are no duplicates. So what is the time complexity for this? If I make use of unordered set, insertion happens in big of 1, right? How many insertions are we doing? If we consider length of our nums is n, we are doing n insertions. So for one element it is big of 1. So for n elements it will be big of n. Right? Insertion into unordered set. Okay, so we are inserting n elements, so it is big of n. Are we performing any other operations? No, we are just inserting and checking the length, correct? So can I say the overall time complexity for this approach will be big of n. Now let me show you the code for this. Okay, I have created an unordered set. The data type of unordered set is int. Now what I'm doing is I keep on inserting all the elements from nums to set. So I'm inserting with the help of insert function. Now I'm checking if nums.size is not equal to s.size, we need to return true, because in that case there will be duplicates. If they are equal, we will be returning false, saying that there are no duplicates. So this is how we can solve this problem. If I run this, the sample test cases gets executed. They got accepted. If I submit this, even this gets accepted. Now we have one more approach, that is using map, unordered map. Let me explain you with the help of that example. So if I consider the same example, it was 1 2 3 1, right? This is our nums array. We know that. Okay, let us try to create a frequency of each element. What is the frequency of 1? Let us run a loop. What is the frequency of 1? Currently it is 1. Let me write it as element and frequency. What is the frequency of 2? Currently it is 1. What is the frequency of 3? 1. What about 1? 1 is already present, so let us increase the frequency of 1. Now it is 2, right? Now we have created frequency of all the elements. Now we know that if there is any duplicates, the frequency of any one element will be greater than 1, right? So element 1 frequency is greater than 1. That means there is a duplicate. So we can return true. Correct? So in order to create frequency of each element, we can make use of map. So map consists of two things, key and value. In map, key is unique, so element will be unique, and in values we will keep track of frequencies. So how are we trying to solve this? We are just iterating the nums array and creating the frequency map. Once it is done, we are iterating the frequency map and checking if it is great. If the frequency of any element is greater than 1, then we know that there is a duplicate element. So we can optimize this iteration, that is iterating the map, with the help of while increasing the frequency. If our frequency of element is greater than 1, then at that point we can say that there is a duplicate element. We don't have to create frequency of rest all elements. So let me show you the code for this. I have created an unordered map. We know that map consists of two things, key and value. The data type of key and value are int. So my map name is frequency map. Now what I'm trying to do is, I'm trying to create frequency of each element. So I'm iterating for nums array and I'm updating my frequency map for each element. After updating each element, I'm checking whether frequency of any element, currently updated element, if it is greater than 1, I am returning true, saying that I found a duplicate. I don't have to check for rest all elements. If this is not true, I am returning false. So time complexity is big O of n. If I run this for sample test cases, this get accepted. Now if I submit this get accepted for hidden test cases. Yeah, this got accepted. So this is how we solve this question, contains duplicate. Thank you.